Hello, my people. I just want to quickly go over some of the rules for naming ionic compounds. Hopefully, this will start to clear some things up for you guys. So, first thing I want to talk about is writing ions based on where they are on the periodic table. So, what you should be able to do is look at a periodic table and just know based on what group each element is in what the ion it's going to make is. Okay, these guys right here, the alkali metals, they form +1 charges because they have 1 valence electron. These guys here form +2 charges because they have 2 valence electrons. These guys here form +3 charges because they have 3 valence electrons. And then once you start to get into the non-metals, you're going to see them start to gain electrons. Okay, so a nitrogen has 5 valence electrons. It needs to gain 3 electrons to have a full valence shell. So it's going to have a charge of -3 because it's going to gain 3 electrons. Oxygen needs to gain 2 electrons. So everybody in this group is going to have a charge of -2. And then in this group, this is called the halogens right here. They all have 7 valence electrons, so they need to gain 1. Okay, and then recall that the noble gases have full shells. They don't really form ions. Okay, quickly as a refresher, I just want to go over where you can find the non-metals. Okay, everything that I am highlighting in yellow here, those are all non-metals. Okay, and then the metals are everything. So you'll see on the periodic table, for example, in my room, you'll see this staircase. Okay. Okay, and everything on the staircase is a metalloid. Okay, so these guys right here, these are in this, and this, and this. These are metalloids, okay? So with the exception of aluminum, everything touching the staircase is a metalloid, okay? So here you have the nonmetals, and then in this lime green, you have what are called the metalloids. And then over here, you have your metals, okay? Everything from here on over, okay? And then specifically, these guys right here are called the transition metals. Everything in red, these are all of this stuff. Those are all metals, okay? So based on the above periodic table, write the formula for the following ions. That's something you're gonna do on your own, okay? Transition metals are in the middle of the periodic table. And they typically form more than 1 ion, with the exception of zinc and silver, which always forms ions of Zn is 2+ and Ag+, respectively. The charge of the transition metal is always, so with the exception of zinc and silver, the charge of the transition metal is always represented with Roman numerals. Okay. So this is something you're going to do. Write the formula for the following transition metal ions. Okay, I'll do the first one. Iron 2 is Fe, and then the Roman numeral indicates the charge, 2 plus. And then write the name of the following transition metal ions. I'll do the first one again. Fe3 plus would be iron 3. Okay. And an ionic compound, I just thought that I wasn't recording. I almost freaked out. An ionic compound is when a nonmetal ion and a metal ion form an attraction. Okay. A binary ionic compound is when there are only 2 elements in the ionic compound. For a binary ionic compound, writing the name is simple. The metal ion, which always goes first in the formula, keeps the same name as the neutral element. The metal ion is always positive because metals lose electrons. Another name for positive ions we know are cations. I positively hate cats. The nonmetal ion, which always goes second in the formula, changes the end of its name to IDE. The nonmetal ion is always negative because nonmetals lose electrons. Negative ions are also known as anions. Okay, write the name for the following binary ionic compounds. Okay, we know that zinc is one of the exceptions where you don't need to write the Roman numerals next to the transition metal. So this first one would be zinc chloride. You guys do the other ones on your own. To write the formula for a binary ionic compound, first write the formula of the ions out, then crisscross the charges to find what the ratio of the ions will be. Example, write the formula for calcium chloride. Ca, so we know that calcium Ca2 plus because it's in group 2. We know that chloride is Cl minus because it's in group 7A, the halogens. And we crisscross these charges to find what the ratio of the ions will be. So we have Ca, Cl2, because you need 2 negative charges to balance out the 2 plus charge. Okay, write the formula for the following binary ionic compounds. You do that on your own. Polyatomic ions are ions with more than one atom in them. Okay, ionic compounds with polyatomic ions are called ternary ionic compounds. Write the formula for the following polyatomic ions. So this is just, you're going to look at your list. I know that sulfates, SO42 minus, you do the rest of those on your own. When writing the formula for a ternary ionic compound, if there is more than one of the polyatomic ion, make sure you put the ion in parentheses and put the subscript outside of the parentheses. So the example is write the formula for barium phosphate. So I know that barium being in group 2 is Ba2 plus, and then phosphate is PO4 just by looking at the list, PO4 3 minus. The 2 is going to go over here, the 3 is going to go over here. So we get Ba3, and then there's more than one phosphate here, so I'm going to have to put parentheses PO4 2. Okay, write the formula for the following compounds. And then, so you do those on your own. And then lastly, it says, when writing the name of a ternary ionic compound, just figure out what the name of the polyatomic ions are in the compound and name. Okay, so I know in this case, MnCO3, I know that CO3, this is CO3 2 minus, and Mn2 plus. Okay, so I know that Mn2 plus I know that Mn is manganese, which is a transition metal. So this should be manganese 2 because I need to put the charge in Roman numerals because it is a transition metal. And then CO3 2 minus is going to be carbonate, manganese 2 carbonate. Okay, so just do the rest of these on your own and have a wonderful rest of your day.